In today's lecture, I want to talk about a problem in present worth comparisons that can arise in certain kinds of projects. And we have a special way of dealing with. And the problem, the title of the talk is Capitalized Cost. The problem is when you have projects or assets that last forever. We've looked in previous lectures at comparing alternatives with different service lives. But in some kinds of projects, there is no service life. Whatever you're building is designed to last forever. For example, if you're building a highway, you don't build a highway with a certain service life. You build it and you expect it to last forever with ongoing maintenance, which might include repaving or painting new stripes or whatever. Or if you build a dam, a hydroelectric dam, you don't expect it to wear out after 20 years and have to be replaced. It's designed to last forever. Or bridges, or even office buildings. They're not designed with a service life. They're designed so that their behavior now, or 100 years from now, or 1,000 years from now, is going to be the same given proper maintenance. So determining a service life is not straightforward here. The way we do this is actually quite reasonable. The idea is that for a particular asset that lasts forever, there are going to be two kinds of costs. There's going to be a first cost, which I'll call P prime, first cost. And there's going to be some annual net costs. Annual net costs will be the maintenance costs. Now, I call them annual cost. The idea here is that no matter what kind of maintenance is required, it really comes down to being an annuity. If you have to repave the highway every 20 years at a cost of $1 million a kilometer, that happens every 20 years, now 20 years later, and so forth. And so it's an annuity. So that annuity can be converted into a yearly annuity fairly straightforwardly. The distinction here is, though, that the annuity has no termination. It goes on forever. But really, there's two kinds of costs. A first cost and what can be considered to be an annual annuity. It's net because it's disbursements minus revenues. So it's a net cost. And there's also an interest rate. Now, the formula then for determining a present worth for such a project is very straightforward. Is the first cost plus this component of capital A over I. Now, how this works is as follows. Let's say you wanted to, let's say you put $100 in the bank. $100 in the bank at 10% interest, let's say you're earning in your bank account. To determine the amount of money you get, you take that amount of $100 multiplied by the interest rate of, say, 10%. And that gives you $10 per year. So if I put the money in today, a year from now, if you like, I get $10. But a year from now, I'd have that $10, and I'd still have the $100. So let's say I take that $10 out and I spend it. A year later, I get another $10, and I can spend that. And a year later, I'd have another $10, and I could spend that. And in fact, by putting that $100 in the bank today, I will get, if I never take it out of the bank at 10% interest, $10 as an annuity forever. I get it a year from now, 2 years from now, 3 years from now, 100 years from now, 1,000 years from now. As long as the interest rate stays the same and my $100 stays the same, I'll always get that $10. So there's, if you like, an equivalence here between an annuity of $10 a year forever and $100 today. That $100 today, if you like, is lost because it's in the bank earning this interest forever, and I can never take it out if I'm going to get that annuity forever. So it's a fair equivalence. So that $100 we can call a present worth. That 10% is an interest rate, and that annuity is a capital A. I can take that I to the right-hand side, and I get that present worth is equal to A over I. So there's a a natural logical comparison between a present worth and annuity if that annuity lasts forever, of the present worth is equal to the annuity divided by the interest rate. So that's where the second half of this formula comes out. If you have that cost of $10 a year, that's the equivalent to a present worth of $100, or in general, A over I. Let's look at an example of this principle. Let's say we're building some bridges. Bridges are the kind of thing that lasts forever. You don't build a bridge with a service life. We have a first cost and maintenance charges for each of these two alternatives, A and B. We're given an interest rate of 10%. We want to determine which proposal is economically preferred. Now, when you're looking at word problems like this, and you don't, it's not obvious that it's a project that lasts forever because you're not told. You just say an alternative bridge design. You can usually tell just by the nature of the project, something that doesn't wear out. You can also tell in word problems that when a service life isn't given. But in real life, often you have to judge for yourself whether it's appropriate to use capitalized cost or simply a comparison method where service lives are involved. Now, our formula is P is equal to P prime plus A over I. For alternative A, our P prime is $10 million. Our A is $1 million. And I, of course, for both is 10%. So our present worth is going to be the $10 million first cost plus the $1 million annual cost divided by 0.1 works out to be $20 million, because $1 million divided by 0.1 is $10 million. 10 million plus 10 million is 20 million. For alternative B, our P prime is 16 million. Our A is 500,000. And the interest rate's the same, 10%. So our P is 16 million. Our present worth is 16 million plus 500,000 divided by 0.1. 500,000 divided by 0.1 is, of course, 5 million. So that gives $21 million. In our present worth comparison, these are costs. So it's the cheaper one that's better. The cheaper one is the $20 million from alternative A. And so we'd recommend it on the grounds that it's economically preferred. So in the capitalized cost approach, we're dealing with alternatives where there's no service life, where costs go on forever. We can find a present worth by using this capitalized cost formula, in particular using the A over I, and it allows a fair comparison of these projects that last forever. Thank you.